Today I'm going to show you how to apply the Hamming code process with even parity to a code word. So this is our code word, and this is how many bits are in that code word. First of all, we want to find how many bits are a factor of 2 out of this code word. So the first bit is a factor of 2, the second bit's a factor of 2, 3 isn't, 4 is, 5 isn't a factor of 2, 6 isn't, neither is 7, but 8 is a factor of 2. So it gives us a total of 4 parity bits that we need to insert into our code word. As you can see, I've already prepared the slots in the code word where we have to insert those parity bits. The parity bits will always be inserted in 1, 2, 4, 8, 16, 32, and so on. Our code word is a fairly small one, so thankfully we don't need that many parity bits. First of all, we're gonna solve for the parity bit at position 8. And we want to assume even parity, so we want to maintain an even number. We're going to see how many, we're going to check how many bits have an 8 in them. So this is a 0, doesn't really do anything. We're already at 0. 0's an even number. We got another 0, again, doesn't do anything. We got a 1. Now we're at an odd number. This is bad. We want to maintain an even parity. We just got another 1. We're at 2. We're back to that even parity. So we're at 2 right now. So we're going to put a 0 in the 8 slot to maintain that even number, that even parity. Next, we're going to solve for parity bit 4. And parity bit 4 is going to focus on all the bits that have a 4 in them. So first of all, we start with this one. This one's a 0, doesn't do anything. We're already at 0. It's already an even number. Again, we got another 0. We got a 1. We're at an uneven parity. We got another 1. We're back at an even parity. And now we're at parity bit 4. So far we have 2. We want to maintain that even parity, so we're going to put in a 0 in parity bit 4. Now we're going to move on to parity bit 2, and we're going to focus on all the bits that have a 2 in them. So we're starting back here. We got a 0, doesn't do anything. We got a 1. Now we're at an uneven parity. We got a 0, it doesn't do anything. We're still at an uneven parity of 1. We got another 1. Now we're at 2. Now we're back at that even parity again. We got another 1. Now we're at 3. This is bad because now we have 3. That's uneven. We want to maintain that even parity, so we're going to put in a 1 for parity bit 2 to bring it up to 4, because 4 is an even number. And finally, we're going to move on to parity bit at position 1, and we're going to start way back here again, and it's going to check every second bit. So we're going to check this one. It says 0, doesn't do anything. We're going to check this one. It's a 1. We're at an uneven parity. We check this one. It's a 0. Doesn't do anything. Check this one. It's a 1. We're at 2. Good. Now we're back at that even parity again. We check this one, it's a 1, so it brings us up to 3. This is bad, we're at an uneven parity. And now we're at the actual parity bits. So now we're at 3. We need to make that this parity bit a 1 to bring it up to a 4 to maintain that even parity. And that's how you apply the Hamming code process to a code word. You can also use odd parity if you want, and it's the exact same process except you want to maintain an odd number instead of an even number. So if we had odd parity here, we would just change all these parity bits to, we'd reverse them. So those two ones would become zeros, that would become a 1, that would become a 1, and that would be Hamming code with odd parity.